Okay. Let's see here. All right, concatenate non-zero digits and multiply by sum part 2. This is medium, continuation from yesterday. You're given a string of length m consisting of digits. You're given a 2D integer queries where query says the left and right. For each query, extract the substring from the left to right index, inclusive, then perform the following form: an integer x by concatenating all the non-zero digits from the substring in their original order. Form a new integer x by concatenating all the non-zero digits. Okay. If there are no non-zero digits, x equals 0. Let sum be the sum of the digits x. The answer is equal to x times sum. Return an array of integers answer, where answer I is answer to the ith query. Oh, interesting. So I'm getting a bunch of substrings of the string. Okay, so this is the string. Query 07 is probably all of it, right? Index 0, index 7. 1, 2, 3, or 0, 1, 2, 3, 4, 5, 6, 7. So yes, all of it. So that should be 1, 2, 3, 4 if I ignore the 0 digits. Sum would be 10. 1, 2, 3, 1, 2 plus 2, 1 plus 2 plus 3 plus 4 is 10. So 10 times 1, 2, 3, 4 is 12, 3, 4, 0. 1 to 3 is 0, 2, 0. So the non-zero is just 2. 2 times 2 is 4. And then 4 to 6 is going to be 3, 0, 0, 4. No. 4, 5, 6, 3, 0, 0. So non-zero is just 3. 3 times 3 is 9. Yeah, okay. All right, I understand it. I think I should probably sort the queries because I kind of want to parse left to right the string. If I parse left to right the string, I think I can keep track of this substring value or some version of it. Yeah. So for instance, queries 0, 7, 1, 3, 4, 6 is sorted by ascending first or left bound of the query. So how would I do it if it's sorted like that? So if I go all the way to 7, doesn't seem right. Well, 0, 7. 0, 7, 1 to 3, 4 to 6. 1, then 2, then 3, then 4. I assume the answer has to be n log n. Can't, yeah, 10 to the 5th. I can't be doing 10 squared, or I can't be doing n squared time complexity for this one. So I'm pretty sure it's n log n for the time complexity of the optimal solution or efficient solution. Maybe it's O of n. Probably not. do. If I parse 0 to 7, I get 1, 2, 3, 4. Then how would I shrink? I shrink on the left side. Shrink on the left side. So I remove the 1 and get 2, 3, 4. But then I need to shrink on the right side for the 3. 1, 3, 4, 6. Zero, 7, 1, 2. Yeah, the query can be pretty much the whole length. I mean, I could convert the string into an array of integers or array of integer digits. How to quickly concatenate, quickly form the digits into a single number without having to do it O of D operation, where D is the number of digits. Hmm. 0, 7. 0, 1, 3, 4, 6. One, 3 just encompasses a 2 with some zeros around the 2. 4, 6 encompasses 3 with some 0 around the 3. It's pretty easy. It's pretty easy to find the sum of the digits between these indices. It's pretty straightforward. It's just the concatenation of the digits in the substring. Sum of the digits is whatever. Do a prefix array to handle that. I guess I might as well just do that one little bit now. How to do this. I say it's easy and then I get stumped by it. I guess maybe digits is integer of k for every character in the string. I think that works. Okay, 1, 0, 2. Yeah. Okay, so that works to convert the string into an integer array of digits. And then I need to convert this into a prefix array. I guess I probably start with 0 for every digit in the digits array. Prefix, the last value for it is, or I guess prefix appends the last value plus this digit. Okay, so sum up to the first index is 1, then 3, 3, 6, 6, 6, 10. Yep. So with prefix arrays, you just need to do the summation, or to find the sum of some portion of the digits array, you do like prefix of the end index minus prefix of the starting index. Probably should do mod before I forget. Yeah, okay. So that little, I think that little bit is probably correct. So let's double check here for every query in queries. I guess I should do left, right in queries. Print prefix of the right index minus prefix of the left index. Is it going to be left plus 1? No, I think, or right plus 1. I think that's right. So I'm looking for 10 to, okay, it's incorrect. It should be right plus 1, it looks like. Yeah, so it's me 10, 2, 3, and then 1, 0, 50, or 45, yeah. Okay, so I did the part to find the sum of digits for each query. Now I just need to find how to do the query substring, which is clearly the hardest part. Guess there should be answer is an array. Guess I don't return mod, huh? How would you do this? What's the relationship, or how would you iterate through the indices? One, 3, 4, 6. So as you move further to the right, parsing the indices, you're going to multiply by 10 and add the current digit if it's not a 0. So 1 times 10 plus 2, 12 times 10 plus 3, 123 times 10 plus 4. You store these values. You store these values. 0, 7. So eventually you get to 1, 2, 3, 4 for that. Then you backtrack, or you move the 1 in front, so it becomes 2, 3, 4. Then how would you move the back side? How would you move the back side indices? One. 0, 7. 0, 9, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh, lordy. I mean, I can't store this as an integer, right? It has to be an integer mod. It has to be integer stored within mod. Otherwise, it can be a 10 to the 5th size or 10 to the 5th length integer, which just wouldn't be too large for storage. Almost like I want to store a string. There's no way a string is going to be fast enough. So technically you want to do a mod of this number and 10 to the 9th plus 7 times it by the sum, redo modulo. Boo. 0, 9. Quite feisty. Times 10 plus a number mod. Times 10 plus a number mod. Times 10 plus a number mod. Nine, 8, 7, 6, 5, 4, 3, 2, 1. Mod 10 to the 9th plus 7. 0, 9. Oh, oh boy. This doesn't seem like an easy medium. 1 to 3, 4 to 6. 1 to 3 is 0, 2, 0. Be too slow to get the substring. Too slow to splice it. Splice or slice? I guess the technical term is slice, right? Yeah, too slow to slice the substring. Or slice n of these substrings that are n long. Oh. 1, 2, 3, 4. I mean, I wonder. I could, for the sake of simplification, I could convert all the queries into, or convert the string into non-zero digits, because 0 digits just don't do anything. And then similarly readjust the query so that it is with the updated non-zero input. So here the non-zero input would be like 1, 2, 3, 4, and the queries would be like 0, 3, 1, 1, 2, 2, something like that. I could do that. That would make it so that I don't have to worry about the zeros. At that point, I don't know. I don't know. It would be some work, but wouldn't be that much work. It would be some work, but it wouldn't be that much work. I think, anyways. I mean, I say that, and I don't really have an idea of how to actually do it. Pretty easy to get rid of zeros from the input, but then how to remap queries to that adjusted thing. 07. So 07 be 1 to the 4. Hmm. Do. Yes, maybe if I just looked at these values, these indices independently. If I looked at these indices independently, then I just need to figure out where they remap to. So index 7 maps to index 3. Index 0, it maps to index 0. Kinda. Um, Kind of gnarly, huh? Uh, don't see an easier way of doing it. Okay, let's go and just try query indices. Is going to be, I'll say it's going to be a set right now for every left and right in queries, query indices, or adds both the left and right index, and then convert it to a list. I guess I can just do sorted of the list of Q indices. Just make sure that this is working. All right, so all the indices map to those or converts to that. Sure. Guess I sort of need this to be maybe a hash map, because I'll need to remap it back into queries at some point. So it should be sorted. I guess I'll do QMap. Okay, so now I'm going to convert the input to into something. So I guess I can just do digits because digits is the array of the input. So I guess I could even use this for loop here. Okay, so for every digit, kind of want, yeah, kind of want that. No, I need another. I need indexed loop rather than a for each loop. So for every index in range n, where n is the length of the queries, no, length of the digits, I guess. Same thing, length of string. I guess this needs to have a remap still. I guess this should be if I need to have a remap. I need to have also, this needs to be 2 pointers. I need a pointer to my Q indices. So it's something like if this index is the same index as where my Q pointer is. So Q indices, Q pointer, if the index there is equal to the current index, then I need to have the Q map for this index be equal to what the remap is. Yeah. And then if this is a non-zero digit, so digits at this index not equal to 0, then the remap increments. Okay. Let's go and print out the view map at this point. That's not good. Okay, whoops, I need to actually increment Q map of this index. Q pointer needs to increment here. Okay, so let's double check here. So in the case of 10203004, it's going to remap to that basically, or it's going to condense to that without the zeros. And like 0 set, or see, the indices that I care about are 0, 1, 3, 4, and 6 and 7. So I need to know how those remap to. So 0 remaps to 0. 1 should remap to 0. No, 1 should remap to. 1 should technically remap to 2. No, sorry, 1 should remap to 1. Oh, that's right. It does remap to 1. I'm surprised that worked. I guess it does. Okay, sure. 3 should remap to 0, 1. 3 should remap to 1 as well. 3 remaps to 2. So it's like inclusive the first, exclusive of the last, maybe. So 3 remaps to 2, 4 remaps to 4 remaps to 0, 1, 2, 3, 4. Should still remap to 2. 6 should remap to 3. And 7 should remap to 0, 1, 2, 3, 4, really? Not good. A little inconsistent. Why does 7 remap to 3? So it should be inclusive of the last index, I think. If I do 1 to 3, it's going to give me 1 to 2. 1 to 2 gives me 2, 3. If it's inclusive of the left and right, but then if it's 2, 2, if it's just inclusive of the left, exclusive of the right. 4, 6 is 2, 3. 7. 7, 7, 7, 7 gives me 3. I see, I see. Yeah. Yeah, I'm treating the queries incorrectly. This should be 8 because it's always inclusive of this left index and exclusive of the right index. So it really should be treating this thing as 8 rather than 7. So I'm going to add +1 here. Yeah. So then it doesn't ever reach the last one, I guess, the last index. Then I need some special handling for the last index. 6. What happened to 6 here? Oh, 6 is 7. Okay, yeah. No, that's not right. What's going on here? 7 should be treated as 8. 3 should be treated as 4. 6 should be as... No, okay, I'm missing the 8. Yeah. Missing the 8. I guess that means that I need to manually add it. So Q map of I guess it needs to be the length. There's 8 characters, right? Q map of the length should be the length of the number of non-digits. The length of the length of length of I actually did need to actually create an array for 1, 2, 3, 4. I don't know if I did that. Oh, it's called digits. I knew I did at some point. No, wait, this is prefixes, whatever. Did I ever create the array of non-zero digits? I guess I should just create it here. So QMap of n is equal to length of non-zero. Okay. I think that's right. 1, 1, 4, 2. So 1 to 3 would be 1 to 2. The query 1 to 3 left right index is going to give me 1 to 2 of the 1, 2, 3, 4. And then 4 to 6 is going to give me 2 to 3, 4 to 7. And then 0, 7 is going to give me 0 to 4. Okay, I think that's right. Ooh. Well, I'm not sure if that gave me anything, to be honest. So now I can do something like adjust my queries. So for every index or query index in range of n, where n is the number of queries. No. In range of the length of queries. Let's say left, right is queries at this index. And then I do the left, right mapping. Queries of this index is equal to QMap for the left and QMap for the right. All right, let's go ahead and just see that this is doing it correctly. Shucks, out of range. Okay, I guess which one is out of, oh, should be, whoops, should be right plus 1. Yeah. Still out of range. QMap on the left. Why would this be out of range? Am I using the wrong mapping? Seven goes to 8. 0 goes to 0. 1, 4, 4, 7. 0, 4, 1, 2, 0, 10. I'm not sure. for every Q index in range of the length of queries. Zero, 7, 1, 3, 4, 6. I'm an idiot. Queries at Q index rather than index. Oh my god, I'm such an idiot. Okay, so 0, 4, 1 to 2, 2 to 3. So that these are the adjusted the adjusted query indices for if the queries were to be applied onto a string or an array where the zero values are removed. So the string converts to 1, 2, 3, 4 if it has no zero values, and these queries apply to that kind of just string. Now then, still doesn't really answer the question. Still doesn't really answer the question of how to quickly concatenate stuff. Well, does it? Does it? Let me think about this. What is going on? So 1, 2, 3, 4. This feels very similar to some previous problem. 1 times 10 plus 2. 1 times 10. 1, 2, 3, 4. Could the calculation be 1 times 10 plus 2, and that times 10 plus 3, and that times 10 plus 4. So let's say I had 12. What if I had a prefix 1, 1, 2, 1, 2, 3, 1, 2, 3, 4? It's not really a prefix array, it's more like literally prefixes. So if I wanted to get like 23 from indices 2 through indices, like index 1 through index 2, something like that, I want to get 23. And maybe I know before it's 1 and after it's 1, 2, 3, 4. Is there a way for me to reverse engineer that? Like I would multiply this by multiply this by 1,000, subtract it from this thing. So I get 234. How would I remove the 4 though? Let's say there was a 6 here. It was like 1, 2, 3, 4, 6. So I would need to remove this 4 here. No, I guess I just need to remove the 1 from the 23 here, huh? Right? 1 from the 23. 1 from the 123. So is it just multiplying this thing by multiplying that by the length times, or 10 to the power of that length? It'd be 100, so 123 minus 100. Would that work? Would that work? Would this work in modulo though? Feeling this wouldn't work in modulo. One, two, three. Well, maybe it might work in modulo. Guess I probably should try it. One 23, 23. One, two, three, four. 2, 3, 4. I mean, modulo works with times multiplication addition, so it should maybe in theory work. Uh, okay. Okay. So for every, this is kind of the, I'm not sure what you call this. It really feels like a prefix is the name of this array, but this is more like this is more like a prefix sum. I'll just call this prefix sum. Okay, and this one is actually the prefix. So for every non-zero digit in the non-zero array, I guess I should maybe make prefix start with 0. Prefix append the last number in prefix times 10 plus this non-zero digit, all wrapped up in modulo. And I think this should be like 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. Do, 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 do. What happened to this spacing here? Okay. Okay, 1, 1, 2, 3, 1, 2, 3, 4, yeah. 0, 1, 9, 9, 8, yeah, this is what I wanted. Well, this is what I imagine. I'm not sure if this is really what I want, but I think maybe. Okay, so if I want something that is 0, 7, which maps to 0, 4, 0, 0, 4s, 1, 2, 3, 4, 1, 2, 3, 4. Yeah, that seems right, actually. So I take this value at wow, this is actually O of n. This is not even sorted, huh? Take this value at prefix at the right. So it should be something like yeah, so it should be something like for every left, right in queries at this point, which has been updated. The answer appends. Let's do the calculation here. So the right value is going to be prefix at right. The left value is going to be prefix at left. Okay, I'm not sure if I need those variables. I think I needs to be multiplied times the difference, right? The difference, 10 to the power of the difference. So if it's 1, then 10 to the power first. Yeah. And then the answer appends the right value minus the left value in mod. I think that might be it. I think that might be it. Oh, so there should be right minus left. Oh, whoops. I forgot to do the multiplication, right? This is just the literal concatenated value. So this thing should multiply by times prefix sum for right minus prefix sum of right minus prefix sum of left, the difference. This is a horrible statement here. Okay, let me just go ahead and just decompose this just a little more. Left value, right value. The I'll call this the x value. Yeah, the x value is the right value minus the left value. And then the total is the prefix sum of the right minus prefix sum of the left. Is that right? Quite right. Because the prefix sum is using the original. using the original thing. I probably need to do the prefix sum of the actual modified array. Okay, this thing needs to be prefix sum for every d in digits. Fuck. I guess I probably shouldn't just, I should have this parsing the digits that are non-zero. So parsing this string rather. I think that's right. So prefix sum is gonna equal 0 here for every digit in the non-zero array. Prefix sum appends the last prefix sum value plus this digit. Okay, now I can use the indices left and right. Total, and then append the value of x times total. Index out of range. Okay, yeah, fine. That's totally fair. I think this should be right plus 1, I want to say. Because I did modify the indices. Why would this go out of range, actually? Index. Did I delete n? Length of digits. Okay, yeah. Whoops. This should be now just be length of the number of strings because I used digits because that was supposed to be mapping string. Prefix sum, the last value plus d. Is d not non-zero? Digits at this index. What's going on here? Remap non-zero append digits at this index. Oh, yeah, okay, I did use that conversion. I guess I just use int of this. Oh, technically I did use digits array. Oh, shucks, cahoots. What's going on here? Okay, so I guess I go back to using this thing. Do I? I mean, the conversion's there. Guess I have the digits. I guess I still can use that. Okay, sure. Although, yeah, this should be right. Yeah. Fuck. Okay, let's go ahead and just try to figure this out here. What should this have been, and what is it calculating? Well, that looks that looks pretty good to me. What the fuck? Oh, I should do. No, fuck. I forgot the final modulo. Whoopsie. Okay. All right, see if this runs on the bigger test cases. Ultra. Index out of range, Q pointer. You don't say. Q indices at Q pointer. So this increments for every index in range n, where n is the number of digits in the original string. If this index matches that, increment the Q pointer, the query pointer. What is going on here? Let's go ahead and say print Q indices, or the length of Q indices, and the Q indexes array. What's going on? 80 unique query indices. If this index equals Q indices at this Q pointer, I guess out of range, huh? What is the Q pointer? 80. Nice. Kind of see it. Kind of see it. So there's only 80 here. And then it's trying to find the 80th thing, which this is the 79th thing. Why did this occur? Why did this occur? I guess this means that so increments to plus, so it's moving to this pointer. I guess. Okay, I'm just gonna do a break here. No, I can't do the break here. Okay, I'm gonna do something where if Q pointer not equal to the length of Q indices. Okay, there we go. Or I can just add an extra Q index, maybe Q index infinity. Yeah, it's probably simpler. So that never has the dummy backstop to the array. Then I don't need to have this check each time. Hopefully Q indices being an extra size doesn't screw up any of the other code. I don't think it does. Okay. Maybe it's too slow. Or, yeah, too slow. It's a big test case, huh? Did it go infinite here? Really? Yeah. Did I do my storage of this array actually incorrectly? I did do the prefix so that's actually within the modulo. So it shouldn't be too big. Oh, it's this thing right here times 10 to the whatever. It's just that's okay. I mean, if 10 to the 10 to the 10 to the fifth is it's too long, right? Yowzers. Yeah, this needs to be. It needs to not be that. This is too big, too big, too big. I need to know how to do exponentiation in modulo. Exponentiation in modulo. How do I do that? Pow base exponential mod. Okay. Times pow of base 10. Exponential is right minus left mod. Okay. I think that might do the trick. Okay. I did that in non-timeout time. Not great, huh? Not great. I mean, it's not terrible. Sure, it's twice as slow. Wonder if I did need to sort, to be honest. I think I did need to sort. Although this seems a little. So for every query, add that to the list of query indices, or the set of query indices, sort that list. I did do a lot of overhead here. But this honestly looks like it's giving me a headache if I try to recompute or readjust. Like, what the hell am I even doing? Oh my god. Vibe leak coding. Is there a better way of doing this? Right value, left value times 10. Right value minus left value. Uh, 10 to the right minus left. I mean, I wonder if this is really slow. Probably is, right? Actually, how slow is? How slow is it? Is it O of? Okay, it's fast. I trust Google. I mean, maybe I don't need to decompose it this much, but whatever. Yeah, I'm done. I am done. Some days you are the head of the distribution, and some days you are the tail. Okay, so what to do here? Okay, so the summary here is okay. Easy part is to calculate the prefix or the sum of digits between left, right for each query using a prefix sum array. Like if you don't know how to do that, then you should look up prefix sum arrays. So that's the second part in each query calculation. And then the hard part is to quickly, and when I say quickly, I'm thinking of one speed, calculate x, where x is the non-zero concatenation of, or the concatenation of left to right indices, non-zero digits within that. Broke this into many steps, but the main ones being removed or created a non-zero version or array of digits. So like the string 10203004 becomes the array that is 1, 2, 3, 4. Translated the query left, right, the queries left, right to use indices corresponding to the appropriate indices in the non-zero array. So for instance, if left right was originally 0, 7, in this array it'd be like 0, 4, because you're doing from index from non-zero digit 1 up to and including non-zero digit 4, which is index 3, 4 being, or so like from 0, 7 of S to 0, 3, I guess technically it'd be 0, 4 of non-zero array. So that was a lot of work. That eventually, technically I reused queries after I did that remapping of indices, but that was all this jazz here. Yeah, I had to do a double pointer using the sorted list of unique indices of the queries. So 0, 7, 1, 3, 4, 6, the unique indices, there would be 0, 8, 1, 4, 4, 7. Translating, because this is all going to be inclusive, translating the non-inclusive, translating the 7 into an 8 to be non-inclusive of the ending index. Yeah, and then created prefix array. This is not a prefix sum array, it's literally a prefix array where like one from the non-zero digits where it looks like 1, 2, 3, 4 becomes something like 1, 12, 123, 123, 1, 2, 3, 4. And then use mod within the calculation to not have numbers too big. Like this should be the next digit times 10 or times the previous digit or the previous value times 10 plus the next digit mod 10 to the 9th plus 7. So that was, I called that the prefix array here. And then finally iterate over each query and calculate both x and sum, which I call total of digits, and append the appropriate answer to the answer array. So that was this last iteration for every query. This is the modified query. So prefix left, prefix right. Take the difference of the values left and right. That should give you, for instance, like if you want to do 1, 2, 3, 4 minus 10, 1 times 10 to the third. The 1, 2, 3, 4 minus 1,000 is 2, 3, 4, which is going to be like the relevant string or the relevant x value between those digits, between those indices. So yeah, calculate that, calculate x, calculate the sum of the values of those digits, and then append the answer x times total or x times the sum. Complexity, this is going to be O of n log n technically, since there is a sorting of the unique query indices. It seems a little weird that that's the overall speed of this algorithm because everything else in the algorithm is O of n. But this little step of needing to sort the unique indices causes this thing overall to be O of n log n. I wonder if I can somehow get rid of this. Well, I mean, if I knew how, I probably would have done it, but all the other processes steps is O of n or so, basically iterating over the queries or the digits. Basically like this can be O of O of n. Yeah, it's O of n. O of n, since you kind of need temporary storage for the queries and digits and everything else. All right, cool beans. I'm getting the TLE. I passed 500 test cases. Time limit exception. Oh, well, I hope you got there.